Okay, so for today, for Unit 4, Lesson 2, we're going to look at graphing exponential relations. So we're just going to be looking at more so understanding what that graph looks like and understanding exactly how we would graph it, okay? So we're looking at exponential relations today. So equations of the form y equals ab to the x. As soon as you see an exponent x, not a number, like not squared, squared would be quadratic, you know that it's going to be an exponential relation. When a is equal to 1, the equation y equals ab to the x becomes y equals b to the x, okay? So you don't always have to have that a value there. If it's equal to 1, that's fine. We're going to investigate how that value of b affects our graph of y equals b to the x, okay? So what happens when we change this value of b? So to start, an exponential relation has a constant growth or decay factor. And the way that you figure out a growth or decay factor is quite easy, but what you're going to do is divide. And where you're going to divide from is starting at the bottom. Okay, so this is the same as finding your first or second differences, like you would for linear or quadratic, except for we're going to divide. So you're going to take that those y values, and you're going to do 8 divided by 4, which is equal to 2. 4 divided by 2, which is equal to 2. 2 divided by 1, which is equal to 2. 1 divided by a half, which is equal to 2. A half divided by a quarter equals to 2. A quarter divided by an eighth, that gets a little repetitive, is equal to 2. So when you see that all of your growth factors are the same, you know that it's a growth factor because b is greater than 1, okay? And that how you would write your equation would be y equals 2 to the exponent x. Because you got 2 here for the growth factor, you know that that base is 2, okay? So just a little intro there. When you have, there's a graph there as well. So that is the graphic as well. And you know that is starting small. So we're starting at really, really small number, and we're growing exponentially by a factor of 2. Okay, so you see that we're starting small and you're getting bigger as you go to the right, and that's what it is going to graph our exponential growth. Okay, decay will look different than this. Okay, so for the graph is a curve that approaches the x-axis in one direction and grows in the other. So it approaches the axis to the right and grows to the right. Okay, so when the exponent in a function is a variable, we call it an exponential function. So this is that exponent there they're talking about. The base must be positive, so we can't have a like -2 base, and it cannot equal 0. 0 as the base. Okay, the y-intercept is at 1. So the way that you would write that would be 0, 1. Okay, the function has a horizontal asymptote, a line that gets really close, that the graph gets really close to but never crosses. I hope you've heard that language before for a horizontal asymptote. The equation of the asymptote is y is equal to 1. So if you were to draw a basic graph here, so you have a y-intercept at, not at 1, this is at 0. I apologize. You have a y-intercept at 0, 1, and then your graph is going to go through it very roughly like this. So this is going to get very, 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 very close to this y-axis, to this x-axis, but it's never going to touch it. So that's why we consider, and sometimes you draw it as like a dotted, you can draw it as like a dotted line to show that that is a horizontal asymptote at y equals 0. Okay. Looking at our domain and range, our domain is x's. Okay, so from left to right, this is going to continue going on left forever, and same with it going on right forever. So your domain is just x is an element of the real number system. And then your range is going to be how high up does it go and how far down does it go. Well, it's going to continue going up and up forever. Can it go down and down forever, even into our negative numbers? Nope. So we're going to write y as an element of the real number system, and our restriction is that y has to be greater than 0, and it cannot be equal to 0, right? Because it's never going to touch that asymptote. So you have to have it that it's greater than 0, okay? And don't worry about the finite differences, okay? Here's an example of something that you may be asked to do. So tell whether curve A and curve B show exponential decay or not. So exponential growth, remember I showed you an example, was starting small and we were getting big to the right. Well, now we start big and we get small to the right. Okay, so they both look like they show exponential decay. However, you need to figure out if they actually do or not by using the numbers you're given. So let's look at graph A. Let's create a table of values for it. So your x's and your y's. So graph A is the purple one. So let's start at 2, 1. The next one is 3, 0.44, 4, 0.25, 5, 0.16, and 6, 0.11. Okay. When you are going to take the differences to figure out, sorry, not the differences, to figure out if it's a exponential or growth or decay factor. So what you want to do is write decay factor here. Okay, and we're going to see if it's consistent. So remember, you start at the bottom and you divide up. I'll write the first one for you. So you're going to go 0.11 divided by 0.16. So you should get 0.7. Okay, then you're going to do the same thing, and as you go through, you're going to get 0.64, 0.57, and then 0.44. So these numbers are not the same, okay, if you're looking at this, the 10th decimal place. So therefore, not exponential decay. Okay, is how you would, wow, my writing, sorry. Not exponential decay, because our decay factors are not the same, okay? Then we could do the same for graph B. Let's see if this one is exponential decay. So we'll start at 1, 0.8. Oops, I just wrote. That is my fault. I was looking at the wrong graph. Should have been looking at 1, 0.8, 2, 0.64, 3. My apologies. My eyes wandered to the wrong graph. So 3, 0.51. There we go. I apologize. Okay, so remember that you're going to find that decay factor, if there is one. Start at the bottom and divide up. So 0.33 divided by 0.41, 0.8, 0.8, 0.8, 0.8 when you divide up, doing those. So therefore, it is exponential decay, because it is the same decay factor of 0.8. So you'd actually write your formula as 0.8 to the exponent x. Okay, especially because it goes through that one, so we know we haven't actually moved our graph up or down. Okay. Any questions? Hopefully not there. That's just an example of how you would prove if something is exponential decay or not. Okay. Let's look at another example. Determine whether the graph is exponential. Justify your answer. If it is exponential, is it growth, or what is the growth factor? Okay, so all you're going to do here is find some nice points that you're able to put into a table of values to figure out that growth factor. So you have -1/2, 0, 1, 1, 2, 2, 4, and 3, 8. Those are nice points. Why are they nice points? Because they go right through a T. Or this one I could tell was exactly at a half, but you don't actually have to use that point if you don't feel comfortable. Okay, so write those points out. Okay, so figure out the growth factor. So starting at the bottom, 8 divided by 4 is 2, 4 divided by 2, and keep going. So you do get it's 2, so that therefore the growth factor is 2. So that is how you figure out that question, if it's exponential, and then what the growth factor is. Okay. There's an example of your graph. We looked at it at the beginning as well. But then what happens if you have the opposite, okay, when we actually have exponential decay? What does that look like? So it's going to be y equals a half, so 1 all over 2. So that number's between 0 and 1, okay? So just make, actually, sorry, it's b, not x there. So b is between 0 and 1, okay? It is the identical graph, just flipped and across the y-axis and going the other way. So you have -3, and that's up at 8, rather than before you have +3 up at 8. Okay. However, it's not like you write -2 as the base here. You put it as a fraction 1 all over 2. Okay. So kind of some key ideas you probably want to write down here. If b is greater than 1, the function is an increasing function. It represents exponential growth. Okay. The bigger b is, the faster it increases. So if it is like y equals 2 to the x as an example, or y is equal to 10 to the x, well, this one is going to increase a lot faster. So it increases a lot faster because you are going to have everything as a base of 10. Okay. If b is between 0 and 1, it is a decreasing function, and it represents exponential decay. The closer b is to 0, the faster it decreases. So the closer it is to 0, the faster it decreases. So if you have like y is equal to a half x, that would be y is equal to 0.5 to the exponent x. But then what if you had like y is equal to 3 over 4x, which is y is equal to 0.75x. Well, which one's closer to 0? This one is. So this one is going to have a faster decrease. Okay, so just some thoughts about that, and then you may be asked a couple of questions on those. Okay, so just connecting our ideas from what we've learned today. So the graph of y equals 2 to the x and y equals half x illustrate the following properties. So we just kind of wrote that on our previous slide. They're always going to pass through the point 0, 1 as a y-intercept, okay? The graph will get very close to the x-axis, but it doesn't intersect, which means that it has that horizontal asymptote. Okay, and the graph doesn't have a maximum or minimum because it continues going up and down, okay? So in some examples here, we just looked at basically just this part of the graph, or sorry, the equation. However, sometimes you do have that a value out front, right? That a value is just called your initial value, okay? And that a value here is still called your initial value from that, okay? So it's just as you see a number out front of that equation, outside of that power, like 2 to the n, then you just have an initial value, which means that it like moves up or down on your graph for your y intercept, okay? So for your homework, it's kind of broken into 3 sections, so 1, 2, and 3. So you're just exploring graphs for those questions. 7, 8 is finding an equation from a graph. 9 and 10 are graphing, and then I just want you to try 15, okay? So good luck. Let me know if you have any questions.